We will start discussing antiferromagnetism by noting a few typical features of antiferromagnets. The first one is the fact that the neighboring moments are aligned anti-parallel to each other. So we have the exchange interaction favoring anti-parallel alignment of neighboring moments. The neighboring magnetic moments interact to align anti-parallel to each other. As you can see here, if you concentrate on the neighboring moments, they're all aligned in opposite directions. And number two, it can be considered as two interpenetrating sublattices. So it can be considered as two interpenetrating sublattices of magnetic ions. So you can see we have the blue sublattice, those are pointing up, and the red sublattice, those are basically pointing down. And for temperature less than the Néel temperature, there is spontaneous magnetization in each sublattice. However, the net magnetization is going to be 0, and for T greater than the Néel temperature becomes a paramagnet. The response to the external magnetic field is similar to that of paramagnets. The response to magnetic field resembles paramagnets. The susceptibility is positive and small. For T greater than Tn, the susceptibility varies as C over T plus theta, the Curie-Weiss law. For T less than Tn, susceptibility increases with temperature. And as you can see, there is a cusp here at the Néel temperature. So first it increases, it makes a cusp, and then it starts decreasing as C over T plus theta. So here it varies as C over T plus theta. And the susceptibility for less than Néel temperature we will talk about in more detail. So in summary, an antiferromagnet consists of two interpenetrating sublattices of opposite orientation. The exchange interaction between the neighboring moments favors anti-parallel alignment. For the temperatures less than Néel temperature, there is spontaneous magnetization in each sublattice so that the net magnetization is 0. For T greater than Tn, it becomes a paramagnet. The reaction to external magnetic field resembles that of paramagnets. It's positive and small susceptibility. Susceptibility, however, increases with temperature for T less than Tn, and for T greater than Tn it decreases according to Curie-Weiss law with C over T plus theta dependence.